This interactive visualization compares 4 regression models predicting ICU patients' length of stay by hours. It visualizes 40 patients' ICU records. 5 interlinked views enable model users to make sense of and select models. The model performance chart allows users to select a metric, percentage error or absolute error in this case, to compare model performance in a bar chart. Dark lines indicate 95% confidence intervals. The model similarity matrix shows model pairs' average prediction difference in bars. The smaller the values are, the more similar predictions the two models make. Clicking on a cell, users can select a model pair to compare their prediction errors and values in the two scatter plots. Each axis depicts one model's predictions. Each dot represents one patient. The more aligned the dots are on the diagonal line, the more similar predictions the two models make. The scatter plot on the right projects patients onto 2D charts using dimension reduction. Similar patients are close to each other. The 3 scatter plots are interlinked. Selecting one or more patients filters the other 2 scatter plots to enable the exploration of data subsets. Initially, the feature view overviews the feature information of the 40 cases. The models use 14 measures, assessed hourly for the first 24-hour stay as features. The feature matrix displays measures as rows, hours as columns, and feature information in the cells. Blue-red divergent colors at the back layer of the cells indicate aggregated normalized feature values. Red means the aggregated value is above the cohort average of this measure, whereas blue indicates values below the measure's cohort average. Bars at the front layer of the cells depict 2 selected models' feature contributions. In this case, the bars on the left are for M2 and the bars on the right depict M3. Top 7 features of each model are highlighted in green. Users can adjust the number of top features to highlight using the control at the bottom left. The current feature view indicates M2 thinks pH at the first hour and GCS scores are important, whereas M3 considers respiratory rate, blood pressure, as well as GCS scores contribute more to predicting these 40 patients' length of stay. Clicking on a feature, users can see from the scatter plots how the feature value distributes among the prediction cases in the same blue-red divergent colors. With verbal response at the 24th hour, models tend to overpredict cases when this feature value is above average in red, and underpredict when values are below average. The label at the top indicates the currently selected feature. The filter view displays patient distributions along relevant attributes, such as ICU units and age groups, which can also be used as filters to filter patients. Once an instance is selected from the scatter plots, red lines in the attribute charts indicate this patient's attributes. The bar chart at the corner informs this instance predictions and ground truth. The feature view shows the feature information of the selected instance. Within the table cell, negative feature importance indicates this model considers this feature value lowers the prediction, whereas positive feature importance means the model thinks the feature value increases the prediction. As a use case, the user aims to select an optimal model to predict the length of stay for cardiac vascular patients aged 66 to 70. Upon selecting the corresponding filters, the model overview shows that M3 and M4 have the lowest percentage error, though M4 is slightly better. The model similarity matrix indicates M3 and M4 are most similar in predicting this patient group among the model pairs. She selected 2 models for comparison. From the prediction scatter plots, she sees the 5 patients are aligned on the diagonal line, indicating similar predictions from the 2 models. They also have similar largest errors, around 150 to 160 hours. The feature chart shows 5 patients' average feature value as well as feature contributions by the 2 models. The left side bars represent M3, which generally has higher importance on all features than M4. GCS scores indicate these patients generally went from a coma state to completely oriented, from blue to red colors. Fraction inspired oxygen indicates these patients received high doses of oxygen supply in the first 3 hours. With machine-assisted breathing, patient respiratory rates are unreliable to make predictions, but M3 highlights this measure twice. M3 also highlights GCS scores 3 times at different hours, whereas M4 spreads top important features more diversely, including fraction-inspired oxygen, blood pressure, and glucose. The user thinks that GCS scores less relevant to cardiac vascular patients than cardiac-related measures, such as blood pressure. So upon the analysis, the user decides to choose M4.